pandas dot read CSV and other formats which are there. As we go along, we will read all those different formats. Okay, so today's class will be on Numpy. Okay, introduction to Numpy for data science. You can use Numpy. Numpy is a very powerful language. Okay, according to me, you can do a lot of mathematical numerical computations. Okay, using a Numpy package. Now, what is Numpy? Okay, so we'll see understanding NumPy and then getting started with NumPy, and we'll have some applications that we will work today as a sample. Okay, understanding NumPy. Okay, so what is NumPy? Basically, NumPy is a Python library used for numerical computation. Okay, and what it provides is it provides you with multi-dimensional arrays. Okay, and mathematical function for fast computation. Okay, you can also use these packages for fast computation. Okay, and I can give example like tools for linear algebra, Fourier transform, and random number generation. Okay, we will play around with random number generation with this package. Okay, and you see the beauty, you can generate your own test data with random number generation. Okay, and you don't have to rely on any data set. Okay, and why do we have to learn NumPy? Okay, because it is faster than Python list. Okay, why? Because this NumPy package was implemented in C language. Okay, and this one, the NumPy is more memory efficient, vectorized operation. Okay, what that means is, if you remember, we learned about the basics, while loop, for loop, and all, right? So we don't need a loops here. Okay, so you can use vectorized operation to enhance or quickly develop your application. And the next one is foundation, and it is NumPy is the foundation for many data science libraries like pandas. Oh, sorry. No, I didn't move it actually. That's okay. Okay, so it's a foundation, and NumPy is also a foundation for many data science libraries like Pandas, SciPy, Scikit-learn. Okay, so you cannot, I mean, this NumPy is limited to not only NumPy, you can use it in Pandas as well. Okay, so that's the beauty of this package. Okay, now if you see what is the importance is, it enables your data manipulation and analysis through its array operations. Okay, so we learned about, if you see the inbuilt data types in Python is list, set, dictionary. Okay, we have learned all those things before, right? But when you use the native sets or list within Python, right, the implementation is slow with the Python, but with NumPy, it is quick. Why? Because this program is written in C language, and we are just calling that language here, importing that packages, and we are using those packages. Okay, same thing what I just explained, n dimensional arrays. Okay, creation of n dimension. You know the uh, single dimension arrays, double, okay, dual. We have seen that, right, where you will have rows and columns. Okay, so n dimensional arrays, it supports any type of data that you have, but it supports only numeric. Okay, only numeric, and it also enables the efficient storage in your memory management so that it can retrieve those data and compute very quickly and retrieve those data. Okay, if you see operation on large data set. Okay, and uh, this function, I mean, this NumPy package is very famous with um, basically with scientists and engineers to perform calculation, okay, and aggregation on a large data set. Okay, we'll see how to install the Python, the NumPy package in Python, okay, and how to import the NumPy package in Python, okay, and then we'll create array from a list, and we'll use that built-in functions, okay, to functions like arrange, zeros for creating arrays specific shapes. Okay, you will see that shortly. Okay, initializing arrays with default values, optimizing your workflows. Okay, and next one is we'll learn about the applications, NumPy applications. Okay, so you can use for array indexing and slicing, common mathematical operation like addition, subtraction, multiplication. Okay, when you have a data set where you want to perform all these operations, you can do that. Also, we'll see about data manipulation and analysis. Okay, what does that mean is reshaping. You have a data, okay, you want to reshape, resize your arrays. Okay, say for example, you have say for example, 6-dimensional arrays. Okay, and when you want to uh, size the total dimension array into 4, you can do that. Okay, you have to give a reference. Like if you see iLock uh, in pandas, right? We have seen to call those particular list from a particular location, right? So we can do that. Okay, and next one is the statistical function in NumPy. NumPy statistical function provides tools for summarizing data, okay, including mean, median, variance, and standard deviation. And we'll see all these topics in statistics also. Okay, so this is about the NumPy. Now we'll have some hands-on to understand the NumPy in real time. Okay, so I have added all those content from your PPT to here. Okay, same thing. Okay, nothing new. So whatever is there, I've added. Now let's get some practical hands-on. Okay, so how do we install the NumPy? Okay, so you can use pip install NumPy. Okay, with the Python version that we have installed or loaded the latest version. Okay, so NumPy includes inbuilt. Okay, so you don't have to install it, though if you want to test it out how the installation looks like, you can run this pip command to install your NumPy. Okay, requirement already satisfied. What it says, it's already installed. 213 is the version. Okay, you may need to restart your kernel. So how do you restart your kernel? This is the icon that you see here. Just click on it and then you say don't ask and then restart. Okay, so it is done, and you don't have to run this. Okay, whenever you want to do any installation, this is one time. Okay, otherwise you can put those commands in hash. Okay, so that you don't have to run. This is just for information sake. Okay, now we will import the NumPy package. I'll say import NumPy as np. Okay, now we will create a list. Okay, I'll say array equals np dot. Okay, I'll press array. Okay, function, and I will declare my numbers. Okay, whenever you declare, you have to give a square bracket. I'll declare some number random 2, 3, 4, 5, 6. Okay, then I want to print this array. Okay, how do I print statement? You have to pass array. Okay, so let me run this. Let's see the result. Okay, now we have a array of 1 2 3 4 5 6 numbers. Okay, now we will convert that into 2D array. Okay, how do we do that? 2D array. Okay, I'll create a variable called array 2D. Okay, some name I'll give, equals uh, np dot array. Okay, np dot array. How do I create two-dimensional? Okay, I'll say 1 2 3. Okay, and then I'll put a comma, and again I'll open a square bracket, and I'll say 4 6. Okay, that is the first one is a single dimension array. This is 2D array, and I'll print this statement. It says a field element must be 2 or 3 tuples. Got 4. 1 2 3 4. Okay, 1 2. Okay, got it. So here, whenever you use two dimension, you have to pass on one more square braces. Okay, so you get your results here. Okay, now we will use some special arrays. Okay, all these are just examples. Okay, I'll create a variable called zeros equals np dot zero zeros. Okay, and then I will create 3 into 3 matrix. Okay, so I'll say 3 comma 3. Okay, so what is this? This is 3 3 into 3 matrix. Okay, of zeros. Okay, okay, I didn't print here. Print zero is zeros. Okay, now you see 1 2 3 1 2 3. Okay, 3 is to 3 matrix. Okay, so this is just an example. You can create 6 by 3 as well. Okay, see, the first one denotes your rows. Okay, the second one denotes your headings. Okay, now with the same zeros and all this numpy, we will create a random data also. Okay, shortly, if time permits, we'll do it. So I'll just turn this back to 3. Okay, for example, because I have already written a comments there. Now we'll do the ones. Okay, ones equals, I'll say np dot ones. Okay, ones, and then inside I'll say 2 comma 4. Okay, and I'll then print the statement once. Okay, I'll change this to once. Okay, now you see how many rows? First point 2 1 2. Okay, and how many columns? 4 1 2 3 4. Okay, and we'll create one more 4 into 4 identity matrix. Okay, okay, so I'll create identity one variable equals np dot I. Okay, and I'll say 4. Okay, and then I'll print the statement output. Okay, now you see. Now what is happening is here it is little difference. You can see the diagonal number here 1111. Okay, 1234 1234. Okay, this is one way. Okay, these are all the samples, guys, for your learning. Okay, now we'll see. Uh, there is another one called attributes. Okay, we'll see what is array attributes. Okay, so I'll print one example first. I'll say arr array dot uh, n dim. Okay, this is for dimension. Okay, so this array dimension n dim will give the value of 1. Okay, now if you type array dot shape, okay, uh, array dot shape, okay, 6. Okay, from where we got this? The initial one. Okay, this one. ARR we are calling, right? So how many array, sorry, shape is there? 1, 2, 3, 4, 5, 6. Okay, look at the size. Okay, don't get confused from where it is coming. Okay, the first one. You have to look at the variable. ARR dot size. Okay, 6. So the size is 6 because 6 entries are there. Okay, okay, and yeah, last one we'll see about array dot d type. Okay, what does d type gives you? The data type. What data type array has? Okay, integer 64 bit. Okay, clear, guys, so far? Yes, no?
Yes, sir. Yeah,
Indexing and slicing. Okay, now we'll see about the indexing and slicing. Okay, I'll create an array called arr1. Okay, equals np dot array, and then I'll declare some number. Okay, so I'll declare 10, 20, 30, 40, 50. Okay, some number I want to declare. Okay, now I'll say print arr1. Okay, now I'm calling the index here. Okay, so what is the 0 index here? 10. Okay, so this is 0, 1, 2, 3, 4. Same in pandas what we have seen. Okay, it's the same, no changes. Okay, now I'll try one more array 1. I'll call the last one. Okay, what is the last one? 50. Okay, this one. Okay, you can also write it in a print statement also. Okay, so I have directly declared here to print the display on the screen. Okay, I'll write print uh, okay, when you type in print, the other value that you were seeing earlier will be removed. Okay, so this is the beauty of print statement. Whenever you want to eliminate the other uh, messages that you see, okay, when you run the variable directly, right, you can control all those things. Okay, I'll run this. Okay, and you will see the difference. Okay, it says np dot integer 64-bit value is 50. Okay, though we get here 50. Okay, okay. Now I'll write one more. Okay, this time two locations I'll write. Array 1. I'll start from uh, 1 colon 4. Okay. If you recall, we have already learned. Okay, so first is 0, 1, 20. From here, say, 1, 2, 3, 4. Okay, fourth. Before fourth, 1, 2, 3, 4. Okay, so it will give you all three values 20, 30, 40 here. Okay, so it will not pick the last one. Okay, for Python, it starts from here. Actually, that the one which you see 0, 1, 2, that is index. Okay, 1, 2, 3, 4. Okay, and what is the first value? First value is this 20. So 20 to 40, if you want to pick up some specific value and display on your screen or result, show the results, you can use the iloc method to display. Okay, now we'll see. Okay, 2D indexing. So I'll just copy this for time being. I'll mention this as array 2. Okay, and then I'll take this is one array. From here, this is another array. I'll add one more called 60. Okay, and then we have to add this this. Okay, 2D indexing. We'll do 2D indexing now. Okay, so first I'll print the value. Okay, this is the value. Okay, now I want to give some reference index based on the index. Okay, I'll say print square bracket, then I'll say arr2 variable square bracket. I'll use 0 comma 1. Okay, let's see what is the result. 20. Okay, so this is 0 Okay, and this is 1. Okay, so 0 and 1, it is displaying 20. Okay, we'll play one more. I'll press just one. Okay, now I'll run this. You'll see the first value. Okay, so see, this one starts with first column. Okay, so what is the first column we have? Okay, the first value that you see is row. Okay, and the right hand side that you see here reference is the column. Okay, here only one column I'm picking up, but here I am not giving any rows. I'm saying the first row, entire row, paste it. Okay, so it is printing 10, 20, 30 from this example. Okay, if I do the same thing for second, okay, so it will print the first one and the second one. Okay, so see, you need more practice. Please just play around. Okay, add some of the other value. Second. Okay, there is, see, this is 0, 1, 2 is not there. That is the result is empty. Okay, if I add 1, first row is this. This is 0, first row. So it is printing everything. Second row entire. Okay, if I say 1 is to 1, it will print the 0. Okay, so you have to play around with this, all these things. Okay, clear, guys? Any doubt so far? Now we'll see some operations. Okay, okay, now what kind of operations will subtract, multiply, will do addition, okay, all those things, and with a sample. Okay, how Python calculates all those things. Okay, I'll say np dot array function. Okay, inside I will declare some number. Okay, I'll say 1 comma 2 comma 3. Okay, I'll take b value. B is another variable container. I'll say np dot array. I'll declare 4 comma 5 comma 6. Okay, I'll just execute this to see the syntax is correct. Okay, correct. Okay, now we'll write our print statement. I'll say print a plus b. Okay, next I'll say print a multiply by b value. Okay, and I'll write another one, print a, we'll see, a minus b. Okay, let's execute and see some of these operations. Okay, so for the first one, a plus b. Okay, if you see, the first one is 1, 2, 3. Okay, second one is 4, 5, 6. So if you do the addition, what is 4 plus 1? 5. 5 plus 2, 7, and 6 plus 3, 9. Okay, the second operation we said to multiply. Okay, so 4 1 ja 4, 5 2 ja 10, and third one is 6 3 are 18. Okay, and this one is a minus b. Instead of that, I should have done this as uh, b minus a. Okay, now you have 3 3 3. 4 minus 1 3, 5 minus 2 3, and 6 minus 3 3. Okay, so these are some of the operations that you can give it a try to get some good hands on. Okay, so next one what we'll do is we will practice on some of the functions. Okay, I'll just copy this. I don't want to type again all these things. I'll just copy it, and then I'll just change the variable name as 3. Okay, so this is my number 10 20 30 40 50. Okay, which is stored on array 3. Okay, now I'll do some useful functions. Okay, I need to add a to useful functions. I'll say print in numpy dot array. Okay, numpy dot array. Sorry, not array. Numpy dot mean. Okay, so we'll see the what is the average of these 5 numbers. Okay, and I have to pass array 3 inside. Okay, so let me run this. So the average is 30. If you add all this sum by 5 divided by 5, you will get 30. Okay, this is our main value. Okay, same thing. I'll just copy this. 1 minute, I can. I'll duplicate this. Okay, now what I'll do is already we have seen the average of those 6 numbers. Sorry, 5 numbers. Now we'll see the other function. Okay, what is the other function? Dot median. Okay, what is the mid value? 30. Okay, so in statistics the median is the number that lies in between. Okay, right now we have these two. What is the mid value? 30. Okay, now we'll try one more. Print uh, np dot std. Okay, so std stands for standard deviation. Okay, and what is the number we want to pass? ARR3. Okay, so 14 is our number. Okay, so if you see all these numbers, right, the standard deviation is 14. Okay, I'll just add few cells here. Then we'll try also the sum. Print np dot sum. Okay, if you add all these 5 numbers, this is your sum addition. Okay, now what is the minimum number here? Let's try this out. NP dot minimum, MIN. Okay, with the sample you can see the minimum number is 10, and we'll say likewise we'll try for max number. Okay, NP dot max, then array 2. Okay, oh okay, instead of NP I have typed NO. Okay, NP. So 60 is the max number from our sample, this one.
Error 3.
Oh sorry, here I have to type 3. Good catch. Okay, 50. Okay, so when you have 10,000 rows, you want to see what is the min and max number, you'll use these functions, okay, on your data set. So these are very useful commands, guys, very useful. So these are all one line examples that you can also practice. Okay, now next one we'll see H2. Okay, reshaping, and there is and flattening. Okay, so I'll create an array 0 1. Okay, you can take any variable. So I'll say np dot, I'll press this tab. I'm looking for arrange, ARR. Sorry, a range. Sorry. Okay, I typed incorrectly. Okay, np dot a arrange 1 comma 13. Okay, now if I run this, okay, first I'll print this to show you the output. Okay, ARR, uh, ARR01, name array is not defined. Okay, this I have not run or what? Okay, yeah, okay. Now you see, so a range I gave you, I gave 1 to 13. Okay, I'll pick 1 to 27. Okay, okay. Now you see, I have number from 1 to 27. Okay, 27 is the last number, so it will not print. It will print the before number, which is 26. Okay. Now I want to reshape it. Reshape. Okay, I'll say reshaped. Some name I'll give. Uh, array ARR 01 dot. We have something called function reshaped. Reshape. Sorry, not reshape. Reshape. Okay. So this number I want to split 3 comma 4. Okay, and then I want to print it. I'll say print reshaped statement. Okay, I'll run this. Reshaped reshaped. Okay, cannot reshape array of size 26 into 3 4. Okay, I'll take 13. Okay, so so you have to remember this, guys. Okay, so first one is rows. Okay, always remember first column is row. So how many rows we are saying? Three rows by four columns. Okay, so you can use this reshape also. Very useful, guys. Okay, now we'll see the flattened. Flattened equals reshaped, reshaped, reshaped dot flatten. Okay, flatten is the command. Okay, and then I'll print the statement. Okay, I'll run this. Now let's see how the results come in. Okay, so this is in a form of, see, first it was in a flattened data set. Okay, then we reshaped it to 3 is to 4 columns. Okay, 3 by 4 matrix. Okay, and then again we have brought that number into a flattened shape. Okay, this is the meaning of reshaping and flattening. Okay. Okay, next one we'll see stacking, splitting. Okay, I'll copy few things here. Okay, now you see same thing. Okay, A and B we already created. Okay, with two-dimensional array. Okay, one, two, and B is this one, two-dimension. Okay, and what I'm doing is I'm using a H stack, A comma B. Okay, horizontal stacking. You can see. The first one is horizontal stacking. The second one is vertical stacking. Okay, you see the difference here. Vertical stacking, and then I'm using arrange np dot arrange 1 is to 10, the same number 1 2 3 4 5 6 7 8. Okay, then it has arranged 1 2 3 4 5 6 7 8 9 into 3, array of 3, split. I'm using the function called split array. What is this array? 1 is to 10 by 3. Okay, split it into 3 chunks or 3 buckets, 1 2 3. Okay, and next one, we'll use the random number. I'll say np dot random, okay, dot, there is one more called seeds. Okay, seed. I'll just mention here as some 42. Okay, then I'll print the statement called print np dot random, okay, random dot rand of 3. Okay, so what this random does is whatever the value we have added 42, right? It will randomly print the number. Okay, a seed is nothing but this number, whatever you see in bracket, it will print the random numbers with this number called 42. Okay, you can interchange these and you can see. Okay, there is one more np dot random dot, I think the rand int, yeah, rand int function is there. Okay, it will take three parameters. I'll 3 1 2 comma 5. Okay, I'll print this. So it will print 5 7 3 7 8. Okay, so what it basically doing is it will start from 1. Okay, it will end uh, uh, the last number should be below the number 10. Okay, you see 5 7 3 7 8, some random number it printed. Okay, and this one is your random number, some random numbers you're printing. Okay, this is random integer number. Okay, random integer number. Now we'll try with normal number. Okay, so with this example you'll be able to understand. Random dot normal, normal function. Okay, it will, this will also take three parameter. For instance, I'll go with 1, sorry, 0 1 5 for our understanding. Okay, so the first value that you see, how many values it should have? 5. 1 2 3 4 5. Okay, and the number that we are printing, it should fall between 0 and 1. Okay, you see here this is a point decimal. Okay, okay, I have one more examples. Okay, I think I'll just write down the topic here. With Numpy. Okay, linear algebra with Numpy. So I'll just print this. Okay, so this is a number A. Same thing I copied from the previous one. Numpy dot array. Okay, two dimensional, some random number, and then I'm printing called np dot dot. Okay, this is matrix multiplication dot. Okay, and this this inv, inverse of matrix. Okay, reverse, and this one is eigenvectors. Okay, eigenvalues and vectors. Okay, this we'll learn in uh, machine learning. Okay, this values, what does this mean, eigenvalue and eigenvectors. Okay, so we'll learn this all these things in deep, and there is a mathematics session is also there, but I will give you some YouTube videos, very good videos, you have to go through it. Okay, and you can also do the multiplications also. Okay, for example, I have this. Okay, I have some random number. Okay, list 1 2 3 4 5 numbers. Okay, and what I'm doing is normalizing it, data minus np dot mean. Okay, whatever the average I'm gonna get from this number, I am subtracting, and then I'm doing a multiplication with the standard deviation to get a normalized data set here. Okay, so this is the normalized data set. Okay, this is the value of 0, and this is 7 increasing, and then 1.4. Okay, this is going in minus. Okay, negative 0 minus 0 minus 1. Okay, the value. Okay, normalized value. What are the normalized value here? On the negative side, it is 0 minus 1, and this is your center point 0, and right hand side you can see 7 1.4. Okay, clear guys? Okay, so this one you don't worry. Okay, you practice it, just practice it, because when we are heading with machine learning and all, right, you have to learn all these things. I'll be sharing some videos, mathematics, that is 4 hours training. Okay, you have to do it. Okay, to understand eigenvalues, eigenvectors, and all, because when you do your machine learning run algorithm on your data set, right, you're gonna get this type of value. Okay, how do you interpret these type of values? Okay, and what is this minus 0? Okay, minus, okay, negative side. Okay, and this is 56.56, 56%. Okay, and this is again negative. Okay, so this value, based on these values, you will be doing your analysis on your data and taking a right decision on your data sets. Okay, so this is a very small session. So tomorrow, what is the time now? Okay, we are on top of the hour, almost there. So tomorrow we will learn about Seaborn, and next day. Okay, so tomorrow is Tuesday. Okay, Tuesday we have a session. Okay, Wednesday we don't have. Wednesday, it's a festival, right? So festival we don't have. Again, we'll regroup on Thursday. Okay, is it okay Thursday, or you guys are taking leave, long leave, and going back to your hometown? If that is the case, then I have to check with everybody. You let me know, guys. Okay, but we can have our session tomorrow and Thursday. Okay, one day is exception, Wednesday, so take leave and do a practice. Okay, so practice makes man perfect. So if you practice all these things, change values here and there. Okay, instead of 5, I took 5 values here, you take 10. Okay, 20 values. Okay, and then you can do your practice. Okay, guys. Yes, no,
Yes, sir. Yes, sir.
yes, sir. Okay. Chalo, we'll close this and you can stop the sharing. I'm gonna share this file shortly. 1 minute, I'll share it. Practice, okay? So see, I am doing why? Because I have a good practice now. Okay, so I've been teaching this for a very long time. So I have a good practice. Initially, even I had some hiccups in learning, understanding. Okay, you have this Google with you. Okay, so your partner who can teach you, help you understand your um, uh, anything that is out of your scope here. Okay, so I think everybody can learn this. It's not a rocket science. Everybody can learn this. Okay, so is this Numpy Basics 1? Okay, so tomorrow we'll regroup again sharp 8:30, and we will continue with Seaborn or Matplotlib. So this week